So in this video, I'm going to record about the concept of functions, domain, range, graph, function notation, examples of function. I'll be showing you how to find a domain in range, the implied domain in range. We'll be looking at all that. How to use a graph to visualize the range. Also, this videos or a set of videos will have informal concept of inverse of a function. Okay, how does this reverse or undo the effect of a function? Inverse function as a reflection in line y is equal to x, and a notation of the inverse function f inverse x. Solving fx is equal to 10 is equivalent to finding f inverse of 10. Students should be aware that inverse function exists for one-to-one functions. The domain of f inverse is equal to the range of fx. So all these will be coming in this series of videos that are dealing with functions. You must have done functions in your lower classes. Now let's understand what exactly is a function. A function is a relation in which no two different ordered pairs have the same x coordinate or the first component. So now, what do you mean by an ordered pair? Ordered pair is when you write a coordinates. Like suppose when you write 2, 3, this is called an ordered pair, where this is your x and this is your y. So this is called an ordered pair. So if you have a set of ordered pairs and you have to decide whether it's a function or not. To decide whether it's a function or not, what you can do is you can visualize this rather with help of a what we call mapping diagram. So you have one which is mapped on 3. So this is an ordered pair. I am taking the first ordered pair 1, 3. 2 is mapped on 3. 3 is mapped on 1. So this is your x and this is your y. Therefore it's called an ordered pair. 4 is mapped on 2. Now if you see that over here, now let's read the definition again. A function is a relation in which no two different ordered pairs have the same x coordinate. Look at the x coordinates of each of them. If they don't have the same x coordinate, it is a function. So yes, this is a function. In this case, look at the first component. Here and here, same first component. No, it's not a function. Very simple. So remember that generally they don't ask you this. This is a very conceptual foundational knowledge which is useful at times. And this is called a mapping diagram. So in this case, if you draw the mapping diagram, you'll find that 2 will be mapped on. So if you draw the mapping diagram for this, you'll find that if you just show this 2, so 2 is mapped on 1 and 2 is mapped on 0 as well. So therefore it's not a function. So 1 to many is not a function. Remember that. This is called 1 to many. Many to 1 is a function and 1 to 1 is a function. Algebraic test for functions. Suppose a relation is given as an equation and you have to decide whether it's a function or not. For example, if I give you this, they ask you, is it a function? How do you do that? So what you do is you substitute. If the substitution for any value of x results in at most one value of y, the relation is a function. So you must get, for one value of x, you must get one value of y, basically. That's it. So remember that. So y is equal to 3. So take any value of x. So suppose you've been given this. Suppose you take x as, let's say, any value, let's say 5. So you check 3 into 5 minus 1. So that's 14. So one value of x is giving you one value of y. So it's a one-to-one function. It's a function. Check this one. Y square is equal to x, or x is equal to y square, which I can add y square is equal to x. So I'll take a value of x. Suppose if I take x, my x is, let's say, 9. So y square is equal to 9. Y is equal to plus or minus root 9. So y is equal to plus or minus 3. So what is happening if you see this in terms of mapping diagram? You'll find that you have your 9. Your 9 is getting mapped on plus 3. And 9 is also getting mapped on minus 3. And 1 to many is not a function. So therefore this is not a function. This is a function. So that's the algebraic test. The third example that you need to know is the geometric test. Geometric test or a vertical line test for a function. Suppose we draw possible vertical lines on the graph. If each line cuts the graph at most once, then the relation is a function. If at least one line cuts the graph more than once, then the relation is not a function. So if it cuts more than once, it is not a function. At most once, it is a function. So at most once it should cut. So if I draw any vertical line, it's cutting at one point. Anywhere you draw it, it's cutting at most one point. If you draw here, it's cutting at one point. So it is a function. This is a function. Vertical line test. If you use a vertical line test over here, it cuts at 2 points. So it's not a function. So in this sense, it's a one to many, because one value of x is giving you many value of y. So therefore it's not a function. The same logic is there throughout this part. Function notation, the two function notation. One way of writing function is like this. Function f is such that x is converted to 2x plus 3. So basically, if you're drawing your mapping diagram, for every x, you will get 2x plus 3. So when my x is 0, this will be 3. You just substitute. When my x is 1, this will be 5. This can also be written as, which we generally write, fx is equal to 2x plus 3. So function of x is 2x plus 3. So we can write like this as well. So these are the different ways in which you can write function. You can write like this, or you can write like this. You can also write function as y is equal to 2x plus 3. All these mean the same thing. So this is how you can find function. And to find value of function, you just have to substitute. You are aware of that. So if I give you fx is equal to 2x minus 1 upon x plus 3. Suppose it is some example. Find f of 4. So what I do is I just substitute all the x's which are there. I substitute that as 2 into 4 minus 1, 4 plus 3, 4 to the 8, 7 upon 7. So f of 4 is 1. Means function of 4 is 1. What does it mean? That if this is 4, this gets mapped on 1. If 4 is the input, the output is 1. So remember, this is the input, this is the output. This can also be written as 4, 1. It's the same thing. This and this means the same thing.